All right, today we will be talking about calculus in polar coordinates, areas and tangent lines. And to begin, the first thing would be learn how to sketch a graph in polar coordinates. If we have a curve that is given in polar coordinates, by the formula r equals f of theta. So whenever you see a formula r equals f of theta, that's a curve that is defined in the polar coordinates, because theta is the angle and r is the radius, and r theta are the polar coordinates of the point, as we discussed last time. And so there are two things that I always propose to use here. It's first, you need to find the points where r equals f of theta equals 0. So technically solve the equation f of theta equals 0. Why is it important? Because in the definition of the polar coordinates, I told you that when the radius is 0, anything can be the angle. So you can have many different angles that take you to 0 for any curve. All right. So when you solve this, you are finding all possible thetas for which the radius is 0, which means all angles that take you back to the origin. So the solution of this equation gives you all angles that take you back to the origin of the graph. Now, if you stay at some point, knowing the notions of calculus that we had before, you know that f of theta, if you take the derivative and set it equal to 0, what you're finding is the possible points where the radius reaches its maximum or a minimum, right? And so that will be the second thing here. R prime equals f prime of theta equals 0. So technically that means solve f prime of theta equals 0. And again, when you do this, you find all points where the radius is possibly reaching its maximum or minimum. And I claim that when you know all these angles and these angles, you can draw the graph of the function. Use these points to sketch the graph. Example 1. R equals, let's say, cosine 2 theta. And we always consider theta from 0 to 2 pi because that's the entire circle, right? That's the entire, that's one lap, which represents all possible angles that cover the space. So you're always looking for that to begin with. Now, and then I say sketch the graph. Then you will say, okay, let me solve r equals 0, which means cosine of 2 theta equals 0. What are the angles where cosine 2 theta equals 0? That's 2 theta equal what? Nick?
I don't know the angles off the top of my head.
It's the same problem we solved in last class.
Would 2 theta have to equal pi?
What's the cosine of pi?
That's -1.
-1. And you want the angles that has cosine 0.
2 theta would have to equal pi over 2.
It's pi over 2 plus k times pi. Where k is an integer. And from there, you plug in the possible values of k to find. So here theta will be pi over 4 when we divide by 2 plus k pi over 2. And that theta is when k is 0, you get pi over 4. When k is 1, you get pi over 4 plus pi over 2, so that's 3 pi over 4. When k is 2, you get pi plus pi over 4, that's 5 pi over 4. And when k is 3, you get 3 pi over 2 plus pi over 4, that's 7 pi over 4. And when k is 4, you get 2 pi plus pi over 4, which is larger than 2 pi. So these are the 4 angles where the radius is equal to 0, which means that if I start drawing this graph, along the angle pi over 4, I will head back to the origin. At the angle 3 pi over 4, I will head back to the origin. At the angle 5 pi over 4, I head back to the origin. At the angle 7 pi over 4, I head back to the origin as well. Then we solve r prime. R prime is the derivative of cosine 2 theta, it's minus 2 sine 2 theta, and we solve this equals 0, which gives sine 2 theta equals 0. What are the angles with sine 0?
Is it 0 and pi?
It's k times pi for any k integers. And then you solve for theta because that was 2 theta. So that's k pi over 2. And now you plug in the integers that will give you the answer between 0 and 2 pi for the theta that we are considering. So the first is 0. When you plug in 0, you get theta equals 0. Plug in 1, you get pi over 2. Plug in 2, you get pi. You plug in 3, you get 3 pi over 2. You plug in 5, you get 2 pi, and 2 pi is same as 0. So this gets back here, which is okay because when your function reaches angle 2 pi, technically you are returning to the initial point with theta equals 0. So here are the numbers that we have. 1, 2, 3, 4, 1, 2, 3, 4. Here they are. And now here, for each of these numbers, I need to find the value of the radius. So I'm going to find the value of the radius for each of those. R of 0, that is cosine of 0, that's 1. So here we have radius 1. R of pi over 2, that's cosine of pi, and cosine of pi is minus 1. And remember that these are the points where you possibly have maximum or the minimum of the radius. At this point, it is 1, that's the maximum. At this point, it is minus 1. R of pi, when you compute here, that's b cosine 2 pi, that's 1. And R of 3 pi over 2, that's cosine of 3 pi, that's minus 1. R of 2 pi is R of 0, which is 1. So these are the points that you have. And technically, to end and sketch, I often ask to take those numbers on that angle, on that circle from 0 to 2 pi, and put on this line all those angles that you found here and here. The smallest is 0, so that's 0. Here at 0, you have radius that goes to the maximum. And then what's the next angle? That's pi over 4. So then you get pi over 4, where the angle is pi over 4 and the radius is 0. So the graph starts at 0 when the radius is at its maximum, and it gets down to 0 when the angle is pi over 4. After pi over 4, you can see the next angle is pi over 2. The radius is 0 here, and then from 0 it goes, pi over 2 is minus 1, it goes to its minimum. So it started up there, then gets to 0, then gets to a minimum, started at a maximum, gets to a minimum. And then the angle that comes after pi over 2 is 3 pi over 4, where the radius is 0, so the radius goes back to 0. Started up there, get through 0 to the minimum, gets back to 0. And after 3 pi over 4, you get pi. And at pi, you have the value is 1. So it goes back to its maximum at pi. Then after pi, you get 5 pi over 4, where the radius is 0. So from here, it gets down to 0. And after 5 pi over 4, you get 3 pi over 2, where the radius goes to -1 to its minimum. So it gets down to its minimum again. And after 3 pi over 2, you get 7 pi over 4, where the radius again gets back to 0. And then after 7 pi over 4, what you get? The last one?
2 pi. 2 pi.
2 pi. So you get the 2 pi. Let me put the 2 pi here. And then at 2 pi, it's 1, so it gets back to its maximum at 2 pi. Right? So that's technically how your radius evolves in this case. And this is therefore what you will use to sketch the graph, because this is not a graph, this is just how the radius changes with the angle. And now when you want to sketch that graph, this is what you do. You draw the plane, the XY plane. You know the angle is 0 here, so that's angle 0, theta equals 0. This is angle theta equal pi over 2. That's angle equal theta equal pi. This is angle theta equal 3 pi over 2. And each of the angles points in its direction, right? Theta equal pi points this way. Theta equals 0 points that way. Theta equals pi, 3 pi over 2 points this way. Okay, and we start 0. The angle 0 is right here in this direction. And we say starting there at angle 0, the radius is 1. Angle 0, radius 1. We can put those radius 1 thing on the graph. Radius 1, radius 1, radius 1, radius 1. For each of them, we can put them. And so technically, all the things that we are going to sketch will lie inside a circle of radius 1. So I'm just putting that to make sure that we keep our graph inside that. So the graph that we're about to sketch will lie inside this circle because there's no radius that is larger than 1. So it's going to be all inside here. When we start at angle 0, we are right here. That's what it says. R of 0 is 1. So at 0, the graph is right here. And we are moving, increasing the angles in that positive direction of the angles. Pi over 4 is the next angle that we reach. Pi over 4 is like here, middle. So that's the angle pi over 4. And what happens at pi over 4? The radius gets to 0, right? So starting here with radius 1, the radius has to decrease and get to 0. So it has to decrease and get to 0 along the angle pi over 4. Okay. Then next thing, it says from pi over 4 to pi over 2, the radius cross and gets a negative, right? This is all negative here. So from pi over 4 to pi over 2, everything goes negative. So it flips. When it goes negative, it means it's not going to be here. It's going to be on the other side because the positive direction of the angle is over there, right? Am I making sense? Yeah. So because this thing went negative, it will go off this space and get down here to the negative direction of that line. And coming out of 0, it will come out of 0. And it will end at -1, which is right here for this direction. For this positive direction, -1 is here. So it will head there to get here at -1. Okay. Coming out of here, where is it going?
Back to 0.
Then 0 pi over 4. We reach pi over 2. From pi, we are right here now, okay? So we are heading back to x equals 0, right? So, and that will be using the angle here, which is 3 pi over 4. It should be here, 3 pi over 4. But because it's negative, this angle reflects on the other side. And so it's going to draw back to 0 here from here. And that's the direction of the motion. We go like that, we cross here. Then from here, we continue there. And now we are right here with angle 3 pi over 4. And again, at angle 3 pi over 4, the radius goes back to positive. So it's going to be in the right direction now, which is here. So coming out of here, we go here because now the radius became positive again. And we go positive all the way up to 1, right? 1 at angle pi. Where is the angle pi? It's right here. So we come out of here and we go to 1 here. Are we good there? Now, once you reach 1 at pi, that's here, the radius begins going back down to angle 5 pi over 4, which is here. And it's still positive, so we are right here. And we go back down to 0 along the angle 5 pi over 4. So we will end up here, starting here. So that's how it goes. Back there, and now we are right here with angle 5 pi over 4. Done. And then the angle goes negative. We are here. The angle goes negative, so it reflects up there. It reflects up, and it is this region now. The negative of this is right there because we are right here going to cover this angle, and it's negative, so it reflects up there. And it goes from 0 to -1, and the -1 is at angle 3 pi over 2. 3 pi over 2 is here, -1, it's over here. So we come out of here along this angle, and we are to end here. And that's why we just joined them. So we started here, up, down, up, down, up, and now we are here at angle 3 pi over 2, which is here. and we go from -1 back to 0 at angle 7 pi over 4. 7 pi over 4 is here. And that angle is negative. That's why it reflects up here. So now we are in this region, representing the curve that would have otherwise been here. Because it's negative, it reflects up here. And we go from -1 to 0 here along 7 pi over 4. So we will end here and start there. And so we just join them. So we went up there, got back down to 0. And now we have the last portion from 7 pi over 4 to 2 pi. And it's positive. So it's going to be right there from 7 pi over 4 to 2 pi. And it will go out from 0 here. It goes out from 0. And it ends at 2 pi with 1. That's it. So that's how you would obtain this graph. Starting there, go down, and return there. So this curve is made of 4 loops. It's one loop, another one, a third one, and a fourth one. Any questions? Any questions about this? And so this is what I expect you to be able to show as work on your test when this question is asked. And then a subsequent question on this will be find the area of one loop. And right away, let me explain here again that if we have in polar coordinates a curve that is defined like this, given in polar coordinates, then this area and this angle here is alpha. The angle here for the top is beta. So R equals, let's say, f of theta, alpha less than theta, less than beta. This is what I just drew here. Then the area equals integral from alpha to beta r squared d theta with 1/2. That's how you would find the area, where r is that function f of theta that you have there. This is the new notion. In Cartesian coordinates, when you find the area on the curve, under the curve, all you do is integrate the function. But in polar coordinates, what you are integrating is r squared d theta, and then you take 1/2. Okay, so in this problem, if they ask you to find the area of one loop, then that is going to be 1/2 integral. You find one loop. How did we draw this first one? Let's say we pick this one. So the angle here, what was the angle to start here? We came back here and we wanted to go up. What was the angle? Hello? So what's the angle to come out here?
That 7 pi over 4.
That was 7 pi over 4. Then we came back down here with the angle. Was that really 7 pi over 4? It's this portion. That was 5 pi over 4. The angle to come out here was this angle, 5 pi over 4. And then we go back down here with the one you just said, 7 pi over 4. That's where we get here. So, and it is important to be able to identify the right angles, because if you get them wrong, then the whole thing is wrong, right? So we drew this to come out of here. We got in here with the angle 5 pi over 4, and we got out with 5 pi over 4, and went all the way to close it at 7 pi over 4. And on this graph here, you can see that it is this portion this is one loop here. This is another loop here, right? From 0 back to 0, from 0 back to 0. That's another way you can identify the loop on this alternative graph, right? When the radius goes from 0 to 0, that's one loop. When it goes from 0 to 0, that's another loop. So here you got one loop here, another one here, third one here, and this is one piece and another piece of the fourth loop. And so here r squared, r is cosine of 2 theta. So that'll be cosine 2 theta squared d theta. So this is the integral that will give you the area of one loop. Now let us write the details of this answer. So integral from 5 pi over 4 to 7 pi over 4 of, this is cosine squared 2 theta d theta. And to integrate cosine squared, you need the half or double angle formula, which states that the cosine squared of x is what? How do we get cosine squared? 1 plus cosine 2 theta over 2 sine square x, it's 1 minus cosine 2 theta over 2 So you can use these formulas in these problems when you encounter issues like this. Otherwise, there's no other way you can integrate this. So here, it's cosine squared, so we are going to use this one. This is 2x, okay, if I'm using x. So in our problem, x is 2 theta, so this is going to be 1/2 integral of 5 pi over 4 to 7 pi over 4, 1 plus cosine 2 times 2 theta, this will be 4 theta over 2 d theta. And so that's 1/4 integral of 1 is theta, and the integral of cosine 4 theta is 1/4 sine of 4 theta. And then we plug in 5 pi over 4, then 7 pi over 4. And that is equal to 1/4 7 pi over 4 plus 1/4 sine of 7 pi, because that's 7 pi over 4 times 4, minus 5 pi over 4 plus 1/4 sine of 5 pi. Sine of 5 pi is 0, sine of 7 pi is 0, so we get 7 pi over 4 minus 5 pi over 4, which is 2 pi over 4, it's pi over 2. So pi over 2 divided by 4, that gives you pi over 8. So this is the area of one loop of that curve. Any question? Okay, a second question for the same curve would be find all points where the tangent line is horizontal, for example, or vertical. For that same curve, r equals cosine 2 theta. Now, notice that we answered this question for parametric curves earlier, which were defined x of t, y of t. And here we have r equals cosine 2 theta. Now, the good news about polar coordinates is just that the polar coordinates are just another parameterization of that curve. So here, we know that x is r cosine theta. That's the relationship between Cartesian coordinates and polar coordinates. And r is cosine 2 theta, so that's cosine 2 theta, sine 2 theta. Oh, what am I doing? Cosine 2 theta times cosine theta. Okay. All right. And y is r sine theta. R is cosine 2 theta times sine theta. So this is the parameterization that you would have for that curve. And therefore, the slope dy over dx is equal to y prime over x prime, which is derivative of this cosine 2 theta sine theta prime over cosine 2 theta cosine theta prime. Okay. And how do we find the derivative? This is a product. So we use the product rule. Derivative of cosine, it's going to be -2 sine 2 theta sine theta. Derivative of sine is cosine. That's plus cosine 2 theta cosine theta. Divided by the derivative of cosine here, it's -2 sine 2 theta times cosine theta. And the derivative of cosine is minus sine theta. So that's it. And for the tangent line to be horizontal, we need that this derivative is equal to 0. For it to be vertical, we need that derivative will be either plus or minus infinity, which means that this denominator is equal to 0. So horizontal would imply -2 sine 2 theta sine theta plus cosine 2 theta cosine theta equals 0. And vertical would imply that the denominator is 0. -2 sine 2 theta cosine theta and then solve each of these equations. All right. Any questions?
You walk through solving one of those equations.
Yes, and it's going to be an obvious thing. So if I'm going to solve the first one, if I have that first one, what's going to happen is I'm going to write 2 sine 2 theta over cosine 2 theta equals cosine theta over sine theta, right? Are we good? For the first one.
Yeah.
All right, and this is 2 tangent of 2 theta equals 1 over tangent of theta, right? Okay. And so technically I'm going to say let u equals tangent of theta, a new variable. Or is tangent of 2 theta, it is 2 tangent of theta over what? 1 minus tangent squared of theta, right? Yes, that. Let me write that clearly here. Tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared theta, right? Remember something like this? That's a trig identity, right? Mm-hmm. And then if you use this, you can put it here. So this is 2u over 1 minus u squared. And so here, that's 2 times 2u, that's 4u over 1 minus u squared equals 1 over u. So you get 4u squared equal 1 minus u squared. Are we good? All right, so you can do that. You get 3u squared equals 1. So u equals plus minus 1 over root 3. That being the case, that means tangent of theta is equal plus minus 1 over root 3. What's the angle that has tangent pi over root 1 over root 3? I think it's pi over 6. Why? Because you have cosine of pi over 6 is root 3 over 2, and the sine of pi over 6 is 1/2. So the tangent is this over that, which is 1 over root 3. Okay. So this is pi over 6 plus 2k pi. And for negative 1 over root 3, the angle is negative pi over 6. So that's why you get plus minus pi over 6 plus 2k pi. Where k is an integer. Are we good? Other questions? And then you do the other one similarly, same way. All right, so that's how it's done. We had the area, and we had to find the points for a given tangent in polar and in Cartesian coordinates. The last thing I want to talk about is how you integrate and take derivatives of vectors, given that we are talking about parametric curves here. And first, let me give you this one example. No. Find all points where the tangent line is vertical. Let's you do this first. What's the first step in this?
The first step is to define x and y.
So it's x.
X is r cosine theta, which comes out to e to the theta cosine theta.
Good. And y?
R sine theta, which equals e to the theta sine theta.
Okay. And what next?
Then you take the derivatives of both.
What are they?
Is it e to the theta cosine theta minus e to the theta sine theta?
Right. Yep.
And then e to the theta sine theta minus e to the theta cosine theta.
Not minus.
Plus.
So that's it. And then
And you set up dy over dx.
and the question says vertical, which means which implies what here?
You have to solve for dx.
What?
You have to solve for dx equals 0.
So this denominator is 0. So you need to solve that. In this case, what you get?
It comes out to cosine theta equals sine theta.
Which means tangent of theta is 1. And what are the angles with tangent 1?
Is it pi over 4 plus 2k pi?
Plus k pi. Thank you. That's it. That's what you do. And if you actually want to find the points themselves, because what we found here is just the theta. And if you want to find the points themselves, because it says find all points. If you want to find the points themselves, then you have to plug in theta to find x and y. Or find all the polar coordinates, which means plug in theta to find r. Okay? So here for this K, this is theta equals pi over 4, or theta equals pi over 4 plus pi, that's 5 pi over 4. And if you add more, you're going to be 2 pi and more. So there's only two such angles. And when theta is pi over 4, r is e to the pi over 4. And when theta is 5 pi over 4, r is e to the 5 pi over 4. So these are the 2 points. R e to the pi over 4, angle pi over 4, and e to the 5 pi over 4, angle 5 pi over 4. So these are the 2 points in this case here where the tangent is vertical. And that's for the angles less than 2 pi. Because in this case, you can actually continue for any integer k, you will get a vertical tangent. Any questions? Okay, now let me ask you a subsequent question in this exercise. Find the area of this curve of the region bounded by theta equals 0, theta 2 equals 2 pi, and the curve r equals e to the theta. Let me see here, theta equal from 0 to pi. That's the second part of the question. Find the area of the region bounded by the angles theta equals 0, theta equals pi, and the curve r equals e to the theta. Take 5 minutes on that and give me what you think. Do you have an answer? Want to propose, Matthew?
I'm just gonna. Is it e to the 2 pi over 2?
Well, you show out the work. How do we do?
So a half integral to pi over 0. 1/2 integral to pi over 0.
0 to pi. Mhm.
And then e to theta squared.
E to the theta squared.
D theta.
D theta, that's right.
And then it equals e to the 2 theta.
Correct.
And then you find the integral. Oh, well, it's e 1/2 to e 2 theta x
Over 2. The integral of e to the 2 theta is e to the 2 theta over 2. And then we plug in 0 and pi, and that's it. All right. Is it true? Nope. Minus, you plug in 0, you get minus 1/4. Right. So that's it. This is the area that is enclosed by the curve and the angles theta equals 0 and theta equal pi. Thank you. That's it, and that's it for today. Thank you very much for coming. I see you guys next week. The homework is due on Sunday.
Thank you.
Welcome.
Thank you.